Hello and welcome again. So in this video, I'll be explaining how to find the area under the curve when given a function, right? So as you can see in this particular example, we're given a function f of x equal to x squared minus 1, and we're asked to evaluate the integral from 0 to 3. As you can see, you will have this area right here, and then we're going to have this area right here, right? So the integral will go from 0 to 1, then 1 to 3. So you can split so basically what we're doing is we want to find the integral from 0 to 3 of f of x dx. In other words, the integral from 0 to 3 of x squared minus 1 dx. But like I just mentioned, we can split this integral into two intervals, right? We can go from 0 to 1, then 1 to 3. So let's go ahead and do that. So we can say that integral of 0 to 3 of x squared minus 1 dx equal to the integral from 0 to 1 of x squared minus 1 dx plus the integral from 1 to 3 of x squared minus 1 dx. One thing to note though is that when you have an area under, when the area is below the x-axis, that area will always be negative. And when it's above the x-axis, it will always be positive. And as we will actually see, when we take the integral from 0 to 1, we will find that the area to be negative. So let's go ahead and evaluate that. So I will evaluate this integral first, and then I will evaluate this one, and then sum them up. Okay, let's go ahead. So 0 to 1 of x squared minus 1 dx equals to 1/3 x cubed minus x evaluated from 0 to 1. This equals to 1/3 1 cubed minus 1 minus 1/3 0 minus 0. So because it's a definite integral, we have to place in the values, right? You take the integral of the first one when x equals to 1 at the very top of the limit of the interval rather, minus where we substitute x equals to 0. Okay, so let's simplify this one. We'll get 1/3 1 minus 1. This whole thing goes to 0, so you don't have to worry about that. So you get 1/3 minus 1, which equals to negative 2/3. So this is the first area from 0 to 1. As we can see, we are expecting a negative value since the area is below the x-axis, and that's exactly what we got here. So we go ahead and do the second part of the integration. So 1 to 3 of x squared minus 1 dx. This equals to 1/3 x cubed minus x evaluated from 1 to 3. Again, it's the same function. We are just splitting the interval into two. And this equals to 1/3. So x equals, we substitute at x equals to 3. So 3 cubed minus 3 minus when x equals to 1. So 1/3 1 cubed minus 1. So this equals to 1/3. 3 cubed is 27 minus 3 minus 1/3 1 cubed is 1 minus 1. And this equals 27 divided by 3 is 9 minus 3 minus, okay, minus 1/3 minus 1 is negative 2/3. And this gives us 6 minus is positive, so 2/3. And this gives us so this will give me 20/3, right? So this will be the area from 1 to 3, right? So it's this area right here. Now we have to add them up, right? Because that's what we're trying to do from here. All right, so the total area equals to this area plus this area. So negative 2/3 plus 20/3 will give me 18/3, and this equals to 6. Right? So you can say that the total area equals to 6. And that will be it. I hope this makes sense, and as always, thank you for watching. Please don't forget to subscribe and to like this video. If you have any questions, please leave it in the comment section. I would greatly appreciate it. And just to kind of to summarize the whole thing, just remember, when given this kind of functions, just try to split them into 2 intervals if you have to. And just remember that the area when the area is below the x-axis is always negative, and even when you take the integration of it, you will find a negative value, just like we did here. As always, thank you so much for watching, and if you have any questions, please leave it in the comment section, and have a great day.